What's up guys, it's Brian from Cross Coast Gaming with another Java game programming tutorial. So the last time we left off, we made a cool little way for us to modify the game world after the game had already started, and we can paint around whatever we want. But unfortunately, the enemies don't really appear to be taking notice or adapting to their changing environment. So what we're going to do this time is begin our very simple I guess AI, if you will, artificial intelligence. And what I mean by that is just getting it to respond and adapt to the environment around it. So we don't want it to be crossing over water and dirt and grass so nonchalantly. We want to follow a path that we make for it. So I think what we're going to do this time is we're just going to get to first detect when its environment changes and then stop moving there. And then maybe next time we'll get it to follow the path around whatever turns we take it to. But for now, let's just get it to detect what it's around and respond accordingly. So let's go to the enemy class here. And inside of our update, it's very basic. Pretty much we're saying the first time don't do it because of our clock messes up. And then every other time after the first update, just move to the right. So the first thing we're going to do is we probably want the enemy to have a copy of the grid, tile grid. So after this, let's just pass it the grid as well. And then that means in our instructor for the enemy, we need to say it's going to take a tile grid argument. And we need to make a variable for it up here. And then set that variable. And that way we can access not just the tile that it starts on, but the entire map of tiles all around it. So we have the ability to kind of see and learn what's around us. So now what we're going to do is we're going to make a new method, a Boolean, and we're going to say path continues. And we need to make a Boolean in here. Let's call it answer and set it to true, and then we will return answer at the end. And then instead of our update method, since we're going to be doing more than one line, we need to make brackets around this. And inside of here we're going to say if path continues, then that is when you can move forward. So for our path continues Boolean here, we're going to say let's see. First, let's get our tile. So current, let's call it my tile equals grid.getTile at our, I think it takes an integer, so int of the x divided by 64. Oops, 64. And then our int of our y divided by 64. So the reason we're doing this is because our actual x might be something like 700 or something, right? But the way our get tile works is we're just taking something like each one tile is just marked by one increment instead of 64, even though the actual textures are 64 by 64. So we're taking our x, which is a very precise number on what pixel we're on, and we're dividing that by 64 to say what tile we're on. And then the argument takes integers, so that'll just lower down any decimal points we have to an actual tile. So this is the tile that our enemy is currently on right now. So now we want to get the next tile. And we can actually copy and paste what we have here. And since we're only moving to the right now, we can just say for the x coordinate, we're going to add 1. So one tile over to the right is the next tile. And we're going to say if my tile dot get type equals the type of the next tile, then answer equals true. Actually, I don't like that. Let's say if it's not equal, then we'll set it to false. So it starts true, and it just assumes that the path is going to continue. And then it says, well, wait, if our type of tile isn't the same as the next type of tile, then it's actually false. And it'll return the answer. if path continues. Alright, so let's try it out. Oops. Oh, our wave. We are not passing in the grid after we changed it. So right here we just need to say enemy type. Oh wait, we need to make a getter too. So in the enemy class, let's go down, I guess I'll put it at the very end. Public tile grid get tile grid. I don't know if I should capitalize this or not. Let's capitalize it. And then we'll just return grid. Alright, so now we can go to our wave class and say enemy type dot get tile grid. There we go. Just make sure that's all kosher with the errors. And now let's try running it. So it's going along, and then let's put an obstacle right here. And it should stop when it detects the dirt. Perfect. Cool, cool, cool. Let's try it again with water just to make sure. Awesome. Alright, so we now have our enemies recognizing that the environment is changing around them and stopping here. And the next thing to code, in case you can't really see how this is going to work out in the future, is pretty much you imagine something like this, right? So they have, actually that was one too far over. Something like this, where they recognize a corner here because they're going on one type of tile, and then when they reach another type, they say this isn't right. And so now the next step for next time is just to get them to change directions, notice that the tile above them is of the same type that they're on right now, and then go up. What's up guys, Brian from Cross Coast Gaming with another Java game programming tutorial. What we're going to do is we are going to, well, when we left off, we have our guy here, right? And if you change it to another tile type ahead of him, it will stop. They'll detect the tile type and that will stop moving over that tile. And I've actually spent a lot of time recently working kind of on my own on this game and trying to figure out the best way to do the pathfinding, which is the kind of like the AI of the enemies. And I think I found something that I like. So you can see here, this is, I have two copies of the project that we're working on. One is the one that we have right now on YouTube, and then I copied it and kind of worked on it on my own to figure out the best way to do what we're about to do here. So this is an example. You can see the enemy detects all of the corners and turns on its own. And a big deal for me was making sure that the enemy could kind of on its own be self-reliant and map out its way through the maze. So the way I was going to originally do it, which to be honest would have been easier, is you build the map and then you also have to go back and mark every single corner. So like in the map editor you have to mark every corner so it knows where to turn. But it was important to me that we figure out a way to make the enemy kind of do that on its own, just to make the editing process a lot easier. And so to give you an example of that, if we go ahead in this map here, and you shouldn't have this, this is just showing what we're going to be making here. And I change this grass to dirt, and this dirt to grass. You can see now the enemy totally follows this completely new path. So as long as you just make the map for it, the enemy can figure out on its own where to go. And that's what we're going to be doing over the next 2 or 3 videos probably, this one included. It's a little complicated, I'm not going to lie, but you know, it should work out. This episode's going to be titled Checkpoints, I believe. So without further ado, let's go to our main game project here. And we're going to do a few things. We're going to split up this kind of checkpoint system in a few different videos. So, oops, still running the wrong thing here. There we go. So first what we're going to do is we're actually going to make a new class and call it Checkpoint. And this is just a class we're going to use to actually keep the variables and the data that we need for each turn that the enemy is going to make. So we just need a couple things here. We need a tile to figure out what tile the checkpoint's on. And we need 2 integers. We need the x direction and the y direction. And I'll explain that in a second. But let's make the constructor public checkpoint. It's going to take a tile an X and a Y direction. And then you should know what we're going to do now. We're just going to set all of the variables. All right, so when I say X direction and Y direction, what I mean by that, the way we're going to use that is that's the direction from the enemy's current position that this next checkpoint is at relative to where the enemy is at right now. So if the enemy is, right here, down here, and the next checkpoint is up here, that means the X direction would be 0, right? Assuming it's right here. And the Y direction would be -1 because you're going to be going up on the Y-axis. So that's what the directions are. So next we're going to the enemy class here. Actually, first in the checkpoint class, we need to make getters, otherwise there's no point to have this class. So go to source, generate getters and setters, or you can do it manually. And just create get methods for these 3 variables. All right, and now that we have that, let's save the class here so that warning should go away. Go to the enemy class, and we're going to do a lot of stuff with the enemy class. So I'm trying to decide the best order. I think what we're going to do this time is, first off, we don't need this path continues anymore. So for now, I'll just comment it out. We're going to delete it, but if you put a little slash and then a star and then a star and then a slash, it'll comment this out, meaning that it just won't run this anymore. And you can see we have an error because we're calling it right here. So we can get rid of this inside the update method. We're going to completely overhaul the way the enemy moves. And so now, at the top, we're going to make a couple variables. One is a array list of checkpoints. What is that noise? I think my water bottle's like moving. An array list of checkpoints called checkpoints. And we'll need to import the array list. And then initialize it. This dot checkpoints equals new array list of checkpoint. So this is a list that we're going to store each turn of the map, each checkpoint. After that, we're going to make a private integer array for directions. And then we'll go ahead and initialize that. This dot directions equals new int of 2, so 2 spots. And we're going to initialize both of those spots. So this dot directions at 0 equals 0. And this dot directions at 1 equals 0. And so what this is there's 2 spots, and that corresponds to X and Y. So I'm not sure how you're going to remember this. Just know that 0 is X and 1 is Y. So I'll go ahead and put comments here. You might want to do that as well in case you forget it. So when we say directions and then brackets 1, we're talking about the Y direction that we're going to go. Directions bracket 0 is the X direction. So now what we want to do is make a new method, private int array find next d for find next direction. And we're going to give it a tile called s as a tile to start to. And you could put more descriptive names here, like find next direction instead of find next d, or tile start instead of tile s. But we're going to be making some very long lines here, and brevity might be kind of important with these names. So it's up to you. It could totally work. If you want to be more descriptive, it might actually help. But just in the interest of having these really long lines kind of not look so scary, I'm going to use shorter names. So the way we're going to start this is we're going to say int dir equals new int 2, and then return dir. So this method, when we call it, we're going to pass it in a tile, the start tile. And what that means is we're going to pass it in the tile that the enemy's at right now, where it needs to find the next direction to go to for the checkpoint. And it's going to return an array of integers, which we haven't set yet, but it's going to return this, meaning that we're going to set our directions equal to whatever this method returns to us. So this method's going to calculate what direction we need to go to next, and it's going to give that data back to us. And so the way we're going to do that is we're going to say, first let's make the 4 possible directions we can go, which is up, right, down, left. So we're going to make each of these tiles, tile u equals grid.getTile. And you know, this getTile method that we made in the grid class is kind of not very descriptive in the way I want it. It's kind of like deceiving because we're asking for the x coord and y coord, which would kind of assume that it's going to be some crazy number based on the x position and the y position, which is really the x pixel and the y pixel. But what we're actually doing is we're returning the place inside of the array. So I'm going to say instead of x coord, and I'm inside the tile grid class now, instead of the getTile method, I'm going to say x place and y place. And this isn't going to change anything. It's just going to make it more descriptive of what we're really doing here. X place and y place. So now in the enemy class, grid.getTile at s.get x. Let's see. Let's go in the tile class too and see what that returns. Get x. Okay. So let's make, instead of our tile class, new returns as well. Public int get x place. And we're going to return an int of x divided by 64. Because remember, each of our tiles are 64 pixels long. So if we were to try to return right now, no, I can't because there's errors right now. But if we were to try to return, say, the third tile, we'd actually be getting some crazy long number for x, like 120 or 130 something. So we're going to make these new methods get x place so that we can just return 3. So it divides the actual x coordinate of the pixel divided by 64, which is the length of the tiles here. And we'll make one for y as well. Public int get y place. Return int y divided by 64. Sorry about that. I had to get a drink of water real quick. Where was I? So we made the get x place, get y place. And so now let's go back to our enemy class. And grid.getTile. And we're passing it a tile called s. So say s.get x place, s.get y place, -1. So what we're doing right now is we have tile u, which stands for up, and we're trying to find where that tile is in the grid. So if we run the game, you can imagine we're right here, right? And so the tile right above us in the grid is going to have the same x coordinate, right? The same place along the x array in the grid. And for the y array, it's going to be 1 up, so -1. And that's the tile right above us. So now, we're going to do the same thing for the tile to the right. X place +1, get y place. That's the same kind of deal, you know, 1 over in the x coordinate. And down. And left. So now we have the 4 possible options that we can go to. Up, right, down, left. We have the 4 tiles surrounding our enemy. And so now we're going to say if s.getType is equal to u.getType, then we actually need to put brackets here. Then dir 0 equals 0, and dir 1 equals -1. And then we could say else if s, and this is kind of repetitive. I apologize. And we might simplify it later, but this is just the easiest way to kind of get into decision making for our enemy on where it's going to be pathing to. Is equal to r. Why didn't that work? Oh, equal to r dot get type. Then dir 0 equals 0. Dir 1 equals 1. And remember, 0 for the directions is equal to the x, is equal to the x, and 1 for the directions is equal to the y movement. So if the type that we're on is equal to the type to the right of us, then we want 0 y movement up and down, but we want to go to the right, so that's a positive x movement, so positive 1. And we can actually copy this right here for the last two. Else if, and just change this from right to down, which would make that 1, and this 0, and then change this from right to left, which would make that 0, and this -1. So now, when we call find next direction, we're going to pass in the tile that we're on right now, and we're going to make a placeholder integer right here. We're going to set the 4 possible options, up, right, down, left, for where we're going to move to next. And then we're going to check which one is the same type as us. And when we find one that's the same type as us, you know what, we should make a last case thing here too. Else, and this is just for debugging. That way we can find out if something went wrong. So if we try running it now, I forget what the map looks like. Let's see, else, I guess what we can do is we can say directions equals find next D. Or actually what we should do is we should only do it the first time here. So right here, let's say directions equals, this is just to see if it worked, so we're not going to keep this, but find next D, and we'll pass it the start tile, which is what we pass when we make our enemy up here. And in the else, we'll say x plus equals delta times directions 0, and y plus equals delta times directions 1. So you can see it's going up right now. Never mind the fact that they're spawning faster than they're going. It's because we don't have the speed working. But it's going up right now because it realizes that all 4 possibilities are the same tile type that we have right here. Now, the reason it's going up then is because that's the first one that we check. We first check if up works, and then right, and then down, then left. It's kind of arbitrary. And hopefully you shouldn't be in a spot like this anyways, in a finished map where all 4 possibilities are possible. Let's see, 1, 2, 3. Let's see what happens if we change this in the boot class. 1, 2, 3, and make this dirt. You see now it doesn't go up because it realizes that the tile it's on is not the same type as the tile that's right above it. So this is just the find next direction, and we're going to be making a couple other methods, obviously, to get that full kind of navigation going. Next time we'll probably make the one that actually marks the checkpoints and then starts progressing through them. But that's all for this time, guys. So thanks for watching. Thanks for all your support in the comments. I know a lot of people are, liking the videos and commenting and saying that they really like them and stuff, and I appreciate that. And I'm glad you guys like them. And I'll see you guys next time. What's up, guys? Brian here from Crosscoast Gaming with another Java game programming tutorial. So last time we left off, we made this little find next D method for find next direction, and if we run it, we see our guys detect the tile change right above them, and we'll begin moving downwards. But unfortunately, and if you saw the annotation I put in the video last time, I kind of messed up here on the tiles and directions. And as I said last time, I had just gotten out of like some dental work done, so I blame the painkillers for my terrible math here. But we're going to say if the starting tile, so if S, if the type is the same as up, then the X direction should be 0, right? We're not going to move left to right if the tile we want to go to is above us. And the Y direction is -1. That's right, because we want to go up, which is -Y, towards the upwards tile. But then things get a little bit weird. We say if our tile type is the same as to the right, then the X direction should be 1, and the Y direction should be 0. So they were just mixed up. And I think that's the case of the rest of these two. Type equals down should be 0, 1, and type equals left. This should be -1, 0. All right, so now they should go to the right, I think. Yep. So just due to the order that we coded it in, up, right, down, left, they notice that they can't go up, so they go to the right. All right, so that's an easy fix. And, you know, those kinds of things happen, those little slip-ups, and that's what I think this kind of series is meant to do, really, is, you know, I'm really programming this game live with you guys. It's not like it's a predetermined code that I'm just kind of copying over each lesson. This is kind of a way that you guys can see the easy mistakes that happen and how to fix them. So, for example, go to the tile class, and I've actually been meaning to kind of make an episode that is just us going back and kind of redoing some stuff or retouching some methods, and I think I will do that eventually because we're coding it live together and it's kind of just fast and loose. So, you know, there are ways we can be improving our code little by little. In the tile grid class, that's what I want to go to. Someone mentioned on an episode a while ago when we implemented the draw method for the tile class, we don't actually use it in our tile grid here. See, we're saying tile t equals map at ij, and then we're calling draw quad text, which is this long method we don't really need. So we can get rid of these two lines and actually just replace them with map at ij dot draw. Because that long line, that long draw quad text is already inside of the tile method. So we can just call that directly from the tile itself. So let's try running that. You can see it still works. Nothing broken there. And, you know, if anyone's having trouble getting to where we are right now, I know occasionally there's some comments in the videos about people are having trouble with various errors and stuff. Just a reminder, I think last episode, I put in the description of the video the exact code for all the classes. So if you are having errors that we're not having, feel free to go ahead and copy those in and see if that works itself out. So what we're going to do this time is, last time we made our find next D class, or I'm sorry, method, and this time we're going to make the find next checkpoint. So private checkpoint, find next, I'll say C to keep it short, and we're going to pass it another S, starting tile, and the directions, so an integer array of directions. And what we're going to put in here is the next, so tile next, set it to null for now, checkpoint C, set to null, and null I'm not sure if we actually went over specifically before, but it's just like nothing. Null just means pretty much blank without leaving it blank. It means that we realize that we just initialized this variable, and for the time being we're setting it equal to a null value. We're setting it equal to nothing. And then down at the bottom we're going to return C. So from wherever we call this method from, we're going to do some calculations here to figure out the next checkpoint, C, and then when we're done with these calculations, which is going to go in the middle here, we're going to return that information back to where we called this method from. So we're also going to make a Boolean called found, equal to false, and you could name this however you want. That'll help you remember. For me, found is easy because what we're going to be using it for, so we're going to say while not found, and we're going to do a while loop in here. And so this is just going to keep going forever and ever and ever until eventually we find the next checkpoint. And then when we do, we're going to set found equal to true, so this loop is going to break. So found, the terminology is just that we haven't found the next checkpoint. It's not perfect, and you might want to rename it to something that suits you, but that's up to you. And because we're in a while loop and not a for statement or for loop, we're going to make a counter. So int counter equals 1. And this is what we're going to increment every time here at the bottom of our loop with counter plus plus. And then inside of our loop, we're going to say, what we're checking is if the s.getType, .getType does not equal grid.getTile, and we need to pass the x place and the y place. So for the x place, it's s, which is our starting tile that we're passing in here, .getXplace plus the direction in the x direction right here, multiplied by counter. And we're going to do the same for the y. s.getYplace, and I'll explain this in a second, plus the y direction multiplied by the counter. And this is a long line, and we're going to make brackets there. And what we can actually do is we can move this down here. It doesn't help that much. So, oh, .getType at the end here. GetType. We can also break it up after the x and y, putting a little return there so we can see the entire thing. All right, so what we're doing here is we're checking if the current tile that we're on, because when we pass this in, we're going to pass the current tile that the enemy is on right now for S, the starting tile, and we're going to pass the directions that they're going, that they're headed to. And we get the directions from find next D, if you'll remember here. And what we're going to be doing is we're going to say, we're going to kind of loop through the tiles in the direction we're headed. So if we're headed positive in the x direction, then that means that grid.getTile s.getXplace, so where we are right now, plus direction 0, which is our x. So if we're headed positive in the x direction, then that means that this will be 1. Direction at 0 will be a value of 1. So we're going to multiply 1 times counter, which starts at 1 here. So we're really saying get the tile to the right of us, right? Because we're getting our current x place, but we're adding 1 to it. 1 from the counter plus 1 in our direction. That's only if we're going along the x-axis. Say we're going up on the y. Counter will be 0. I'm sorry. Direction at 0 will be 0. So our x direction will be 0 if we're going up on the y-axis. So when we say get x place of the starting tile, that's where we are, plus 0 times whatever counter is. So we're not moving the x. The y, however, we're getting our current y place plus -1 if we're going up, right? Times counter, which in this case is 1. So it's the tile right above us. I hope that makes sense. Maybe if you guys read it, you'll get it. And some of you, I'm sure, get it right away. Anyway, we're going to increment counter every time. So if we're moving to the right, counter will be 2, then 3, then 4. And it's going to keep going along our current direction until it finds a tile that's not the same as the one we're on. And that represents like a bend in the map. So if we start it right now, say we're here, right? And we're going to the left. We're going to find eventually this tile, this grass. And when we do, we're going to say the checkpoint should be right here, right? Because this is the last tile in this line that's the same as the one we started on. So it's going to say this is the same, this is the same, this is the same, la 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 la, all the way till here. Let's say this is not the same. So let's move back 1 and make a checkpoint right here. And that's where I need to turn. That's what this method's doing. So once we find something that's a different tile type than ours, which is what this if statement's doing here, if our type is not the same as the type we're looking at right now, we're going to first say found equals true, so we don't keep running this while loop because we found the next checkpoint. We're going to say counter minus equals 1, and I'll explain that in a second here. Next, which is the thing we have up here, the tile, equals grid.getTile, and we can actually just copy this entire thing here, minus the type. So we'll say next equals grid.getTile s.getXplace plus direction 0 times counter, blah, blah, blah. It's pretty much the same that we're checking right here, but we're moving back 1. So remember, this if statement isn't going to trigger until we get to right here. We want to find the tile right here, so 1 previous. So that's where we're minusing the counter by 1. We're moving back 1 on the counter and then we're going to say the next tile that the checkpoint's on is right here. So at the bottom, we need to set the checkpoint equal to this data that we have. So remember, we made a checkpoint called C in here, and we're returning C at the bottom. So we say C equals new checkpoint. And what do we need for the constructor? We need the tile that it's on, the X direction, the Y direction. Okay. C equals new checkpoint. Next is the tile the checkpoint's on, which we just set right here. And then for the X direction, that'll be dir 0, and the Y direction will be dir 1. X direction, Y direction. Yep. All right, and so we can actually put some comments in here too, so we remember kind of what we're doing here. And this is just to help us out, so we remember if we have to change some stuff around, make sure that we're not changing anything that breaks it. So let's see, Boolean I'm gonna try to word this before I don't know, you guys can word that however you want, but we're pretty much moving the counter back in order to find the tile right before the next tile type. I think that should work. So I mean, there's not gonna be much different here because we're still implementing this entire class. But next time, I think what we're going to do is we're going to kind of loop together the find next C and find next D methods and kind of populate the entire array list of checkpoints up here, array list checkpoint. So yeah, by the end of the next video, we should be able to find out how to get our enemies to completely map out the map on their own. What's up guys, Brian here with another Java game programming tutorial. So the last time we left off, I think we implemented our find next C or find next checkpoint method. As you can see, our guys here aren't very smart, but I have a feeling that by the end of this video, or maybe the next one, depending on how quick this goes by, we should have our enemies fully operational and making their way through the maze. So that's exciting. So the first thing we're going to do here is we're going to implement a method to populate this list of checkpoints. So we made this array list, which is pretty much just a list of checkpoints that our enemies are going to go through, right? But we never did anything with it. We just kind of named it. So the first thing we're going to do is we're going to go right at the bottom of our constructor here, right above our update method, and we're going to initialize it. So this dot, oh, we already did. Didn't realize that up here. I was going to say we should type this dot checkpoints equals new array list of checkpoint, but we already did that. So the next thing we're going to do is go to, or I guess the first thing we're going to do is make another integer, and it's going to be called current checkpoint. And this is going to keep track of what step along the way from the beginning of the end, or the beginning to the end of the maze that we're at right now. So we're going to initialize that at the bottom of our constructor and say this dot current checkpoint equals 0, because we're starting on the 0th checkpoint. So now we're going to make a new method, and I'm just going to call it, we're going to get a private void, so name it populate checkpoint list. Very specific because we don't need to call it more than once, so why not have a long specific name so we know exactly what it does. So we're going to run this right below where we set our current checkpoint integer. I'm just going to say populate checkpoint list. So this is going to go through and fill the entire list of checkpoints with each turn in the maze, and then we're going to pass that to our enemies so that they know what to do. So for populate checkpoint list, the first thing we're going to do is, well, the first checkpoint here, maybe this would be easier if we go to the boot class first, and we have our guys spawning, I believe, like right here, or right here, if you have the same setup as me. If not, now would probably be a good time to kind of get similar to what I'm doing, because we're going to be working directly with the maze. So I know you guys might have made like custom levels or whatnot. Just try and like save those in Notepad and get something similar to what we're working with here, so it's easier to follow along. But pretty much what the important part is that we're we're having a large map of one tile type, so in my case it's grass, and then we're going to start working with an actual path. So just make sure you have a path that goes preferably from left to right, just so we can debug together and make sure everything's working properly, and then have our enemies spawn on that path. So right now they're spawning too low, so I'm going to bring him up from 10 to 8 on the y-axis and see. Alright, perfect. Now they're spawning on this actual dirt path, so we can test that. And I'm going to make it loop up here, do a little turn, and just make sure that they can properly make the turns once we implement these methods. So back in the enemy class, the first thing we need to do is we're going to actually we're going to make a while loop and kind of keep checking until we've gotten every checkpoint in the maze added to the array list. But the first one, we can't really do that because the first one isn't based on our previous checkpoint or position, it's based on our starting tile. So if you'll recall, we're sending a specific start tile to the enemy where it spawns at. So in our populateCheckpoint list method, the first thing we're going to do is we're going to add the first checkpoint, which is based on our start tile that we sent. So checkpoints, which is the name of our array list, .add, we're adding a new checkpoint because it's empty right now. And we're going to use our method findNextC. So that's the method that we coded together to find our next checkpoint. And inside of it, we're going to pass what we need. Oh, it's right here. We need a tile, and then we need an integer array for the x and y directions. So for the tile, that's going to be start tile. And then for the directions, what we're going to do, we're going to do something a little sneaky here. We're going to set our directions, which is the current enemy directions, which we have right up here, equal to something while passing in a variable. So we haven't done this before yet. So if you're following along and you're not super familiar with Java, then this will be a new concept. But we're going to say directions equals, and we're going to use our other method we made, findNextD. And we made that down here below the findNextC, and that just takes a tile. So we're just going to pass in the start tile. And then that. So what we're doing here, to be more specific, is we're taking our array list of checkpoints, so our list of all the turns in the map that the enemy is going to need to know when to stop and what direction to turn, and we're adding a new one. In this case, it's the very first one. And to do that, we're going to use our method called findNextC, which we coded last time to find where the next checkpoint is from our current position. But because this one isn't like any other current checkpoint, it's the very first one, we have nothing to base it off of. Because you can see in our method here, we're sending a tile to it, and we can't send the same tile as our very first time as everything else because we have no previous data to go off of. So we're sending our start tile in this instance. And then we're sending it directions for x and y. And to get those directions, we're getting it from our method we made, our findNextD, which also takes a tile, and we're passing it back to this method. So this equal sign, it can be pretty much ignored as far as this method is concerned. It doesn't even look at this whole part right here. We're just saying we also want to set our directions equal to what we find from this method here. So we could just as easily have that, and it would work fine as long as we also say we wanted our directions to be equal to findNextD at start tile. It's just a way to combine those into one line and make it simpler. So I'm going to go back and leave it like we had it. So now we're going to make a while loop to go through every other checkpoint. So the first one was a special case, and now we're going to loop through and find the rest of them. So int counter, we're going to do something similar to how we did the last method. Counter equals 0, which is our little thing we're going to increment. And Boolean continue equal, oh, right, I can't do that. We'll say cont equals true. If you're curious, continue is a protected word. See how it turns purple like that? It's because it's actually a term in Java, so we can't name our variables that. So Boolean cont equals true. And then we're going to say while cont. We're going to do all our stuff in here. So this is similar to how I set it up last time. It's not the most efficient, and we're probably going to go back and replace it at some point, but it's just easy to demonstrate that as long as we're continuing to search, then we're going to keep this true, and then when we find what we're looking for, we're going to set to false and stop the while loop. Just an easy way to kind of set that up. So in our while loop, we're going to want to go through the rest of the checkpoints here. So the way we're going to do that is by using our findNextC method. I think you guys are going to be surprised at how helpful these findNextC and findNextD methods are going to be, because it's going to save us a lot of coding. So I know it was kind of a pain to code them in the first place, but they're actually going to be super helpful to us. So first, we should check if we're at the very end of the checkpoints left. So in our findNextD method, we have an else here. So we're saying, you know, if you can't go up and you can't go right, you can't go down, you can't go left. Right now we're just printing out no direction found. But what we should also do is we should actually make that clear to whatever method we're calling this from. Because right now it's just printing. And so the computer can't tell that we're done. Only we can, because we're going to be reading that. What we should be doing is setting, dir at 0 equal to -1, and dir at 1 equal to -1. That way when we call this, you know, we see here, like, if the x is equal to 0 and the y is equal to -1, that means we're going up, and, you know, so on and so forth. If they're both equal to -1, yeah, actually that's not going to work, I just realized, because we're using -1. We should set to 2. So 2 is something that would never ever occur between all these other instances. So now we can check if we get 2 back, that means that there's no direction found, and we shouldn't be relying on the data we get from that. So let's go back up to our populateCheckpoint list, and inside our while loop, we're going to say int an integer array of current d equals findNextD at checkpoints dot get index of I. Don't we need a tile for that? findNextD start tile checkpoints dot get I. Why doesn't that let me get a tile from that? What if I just typed it out? Let's see what the error is. Oh, because then make silly me. All right, instead of I, it should be counter. Used to name it I. All right, so we're getting our direction using our findNextD method, and we're getting it for the current checkpoint we're at right now. 1 second. All right, I'm back. Sorry about that. So we're setting current d equal to findNextDirection at checkpoints.getCounter, which is where we're at right now, .getTile. And then we're going to check if current d at 0, so for the x, is equal to 2, then we're going to set cont equal to false, continue equal to false. So that's the thing we just implemented there, where if the findNextDirection, findNextD, can't find where else to go, it probably means that we shouldn't be still looking for checkpoints. It probably means that we're at the very end of the route or the maze that they're traveling on. And so we're going to stop looping through this while loop. Else, meaning there is a next direction, we're going to add a checkpoint to our checkpoints list. So findNextC, and for this we need a tile, which would be checkpoints dot get I dot, I keep doing I'm sorry guys, dot get counter dot get tile, and we need a direction. So I'm just gonna return to this next line here because it's getting kind of long. The direction is directions equals findNextD at checkpoints dot get counter dot get tile. Why is that not working? Did I not have enough? There we go. It's a lot of parentheses. So we added a new checkpoint to our array list of checkpoints here, and we're in a while loop, so that's going to keep going over and over and over until we've found all the checkpoints, where eventually we'll come to a point where we can't find the next direction, so meaning the direction of the next checkpoint from where we're currently checking, and so it's going to return 2 from the findNextD method. When that happens, we're going to break out of the while loop. But until that happens, we're going to keep looping through, and based on the counter, which we should increment right here, it's going to keep getting higher and higher, so we're going to keep checking for the next checkpoint over and over and over. Okay? So we're going to go back and comment through all this, because it's a lot to digest at once, but I think if you look over it and with the comments, it should make sense, hopefully. It is pretty complicated. Definitely the most complicated stuff we've written so far. But I think that ends our populateCheckpoint list method. So all we actually need to do is implement one last method to check if our enemy has reached the next checkpoint or not, and then we should have a completely autonomous enemy that navigates itself through the maze. But this has already gone on long enough, and I imagine that the next method will probably take almost as long, so I'm going to break it up, and we'll cover that next episode. So the next thing we should do is we will make a private Boolean checkpoint reached method. And we're going to use a Boolean reached. We'll set to false by default. And we're going to return reached. So we're going to call this every time we want to be moving our character here. So instead of our update method, we can actually get rid of, I guess I won't get rid of it yet, but in a second we're going to. We're going to check if checkpoint reached, then move our current checkpoint up 1, else we're going to do our movement. So that's actually not capital P. So if we reach the checkpoint that we're headed towards, our enemy's headed towards, then we're going to say we're on to the next checkpoint. We want to get the next directions, and we want to go to the next corner that we need to turn at. So we're just going to increment our current checkpoint up by 1. So otherwise, if we haven't reached it yet, then we're going to keep moving towards that direction. So that'd be x plus equals delta times, delta times checkpoints dot get current checkpoint. Dot get direction. And y will be y plus equals delta times checkpoints dot get current checkpoint dot get y direction. And now we can get rid of these two down here. So now we'll be consistently moving in the correct direction based on the current checkpoint that we're trying to get to. So we're going to remember each checkpoint, if we go in here, it has an x direction and a y direction. And these are based from our current position. You know, since we're telling it, when we're creating the checkpoints, we're basing this x direction and y direction on where our enemy would be previous to where they need to go to the spot. So we're getting up-to-date information on our x direction and our y direction every time we move our enemy. So they're going to be consistently moving towards the next checkpoint. So let's go to our checkpoint reached method here. And the thing we're going to check is first, we're going to be rewriting the same thing a lot if we don't do this. So I'm just going to make a tile t equals checkpoints dot get current checkpoint dot get tile. So that's where we're at right here, checkpoints dot get current checkpoint. We're trying to figure out if our enemy has reached that checkpoint and can move on to the next one. So we're going to check if our x is greater than t dot get x plus 3 is an arbitrary amount here, and I'll go over that in a second. And I hate the way Eclipse finishes that for me. And x is less than t, I actually mixed it up, t dot get x plus 3. This should be minus 3 right here. And I'll explain this in a second, guys. Y is greater than t dot get y minus 3. And y is less than t dot get y plus 3. So if all of these are true, then we're going to set reached equal to true. So what we're doing here is where x and y are the positions, the current positions of our enemy. This isn't going to work right now because I shouldn't have run that. Don't run it, guys. We're in the middle of updating the methods, so that's not going to work right now. So x and y are the current positions for our enemy, right? And they update every single time the game updates, so it's absolutely up to date. We don't need to get it from anywhere else because we're already inside the enemy class. So we're checking if our x position is greater than the position of the next checkpoint we're trying to reach, minus 3. So I wish there was some way I could, like, I'm going to go for it, guys. I'm going to go for paint here. And I know I have great artistic ability. So pretend that's a square. And our enemy, pretend that's an enemy, is going to the right, okay? So if he's heading this way, we want to check and make sure that his position is greater than the tile position minus 3, which would be, say, about here. And it's less than the tile position plus 3, which would be, I mean, really it'd be about like here, but for illustration, we'll say it's about here, because it's based on the top left corner, but we'll just say center positions. We want to make sure that he's inside this area, which is just barely wider than the actual tile area. And the reason it's a little bit wider is because our speed, remember each enemy has a speed that it moves, so that's the amount of pixels it moves every update. And the small decimal we get from our delta method, and the amount of times we're updating every time we draw the screen, might not always add up. In fact, most likely they will not always add up into a perfect factor of 64, which is what our tiles are based on. So if we're on a map, you might have different size tiles, but I'm working with 64 by 64. So if we're on a tile grid, and it's all 64 by 64 tiles, if our enemy comes stomping along here, and we're just going to check if he is greater than this circle, then he might get a little bit too far before we do that next update, because we might move his speed, say his speed is 7 pixels, he might be right here, one update, and then the next update is right over here. So then he's going to go up, say the next tile is right above him, he's going to start traveling upwards, but he's going to be past the tile. This drawing is so bad, guys. I just hope you should probably just not look and just listen to the words I'm saying, because I have no artistic ability. But what I'm saying is we're giving it some leeway. Just think of it that way. The 3 is just an arbitrary number. You might want to like play around with it on your end as well, until we come up with a way to have a method that just gives us a consistent, good number to use. But it's just some leeway to account for the fact that between the speed and the delta and all these other variables, we might not always have our enemy perfectly line up at a 64 pixel spot where the tile starts. So let's go back to our method here. We're checking if our x position is within a variance of 3. In fact, I'll say that right now. Check if position reached tile within variance of 3. I'll mark it as arbitrary, as in I just made it up. We're going to need some leeway. But if it didn't reach that, if it's within all these boundaries, so it's pretty much on the tile of the checkpoint, then we're going to say it's marked as true. And in fact, we just put brackets because we're going to do more than just mark it as true. We're also going to set our x equal to t.getX and set our y equal to t.getY. And if you understood at all what I was trying to explain a second ago, this should make sense, because we're checking if even if he's, say, at the position of the tile but plus 1 or 2 or 3 pixels, we want to send him back so he's right on track. So we set his x to exactly where it needs to be. Within a variance of 3 pixels. So once this is all working, I hope that, let me know in the comments if I'm just confusing you. But we're setting our x and our y to the perfect 64 factor variables that need to be so that it looks on our screen like he's just perfectly following the turns. And so we're going to set reached equal to true. And then if this fails, we're going to not set to true. So by default, it's set to false. And it'll return reached, which is false. So I'm wondering, why did the game crash last time? What else do we need to implement before this works? How about this? Instead of our populateCheckpoint list, I think we might be going forever and ever and ever until we get a 2 back, but that might not always happen. So let's say or. So current d is 0 equals 2, or, which is those 2 little thing on the backspace or the backslash key. I forget what they're called. Say or counter equals, I don't know, let's say 20 for now. Another arbitrary number. And we'll put a comment so we remember that. Let's see if that helped our game. Okay. So we are here and he's moving. Let's speed up these enemies a little bit. So I'm going to go in the boot class. And the speed, I believe, is 6 right now. Let's try setting it to 12. Why are they so slow? Am I taking crazy pills, guys? Or is that not actually increasing our speed at all? Boot 30. Is that the speed I'm even setting right now? Yeah, speed. Oh, I'm so silly, you guys. Alright, so of course, in the enemy class, when we're moving them forward, right now we're just saying delta times the direction. We should be adding their speed at the end of that. That explains it. And we'll set their speed back down to 3 because 200 would be absolutely ridiculous. I was wondering what was wrong. So now let's try it. Alright, so they're going along here. And hopefully, cross your fingers. Alright, so it detected that corner and it's turning up now. And it's going up to the top. And it didn't detect the left turn, so it's going back. But let's see if going down they detect this turn to the left. Okay, so they had an issue turning left. So let's see. They go up. Let's try giving it a right turn. And this is part of the debugging process. I'm super glad that they found that first turn, and we probably just have a number incorrectly somewhere. Let's see if they can do these turns now. So start going to the right. Sees the upturn. And there's a little, I don't know if you guys can see it in the video, but there's a little like stutter when they turn, and we'll fix that. And they make the right turn okay, and then they go down. They should loop back around from this down part. Alright, perfect. So, I shouldn't say perfect, but huge step forward. So you guys can make crazy elaborate maps, anything your heart can dream of, as long as they only turn up and to the right. We just need to figure out why they have trouble detecting left turns. It's probably just fixing one number. But this video has gone on long enough, and I feel like I've already bombarded you guys with so much stuff. Good job, guys, this time, if you're able to keep track of what's going on. I know it's super confusing. And keep in mind that we're going to go back through this and kind of update it to make it more efficient and also comment all the stuff. So this is just kind of a rough draft, imagine, because we're coding it live.